Based on the information given, we can see that the top strand is the template strand and the bottom strand is the coding strand. Next, we need to identify the reading frame and find the start codon. AUG codes for the amino acid methionine and is the start codon that will be the start of the 4-amino acid protein upon transcription and translation. The mRNA strand is complementary to the template strand, and the coding strand is almost identical to the mRNA sequence. The template strand runs in a 3' to 5' direction, creating an mRNA sequence that runs 5' to 3'. We can see that we have reached the end of translation once we got to the stop codon, which in this case is UAA, thus signaling the end of the protein chain being built. In my opinion, if you rewrite the mRNA sequence in 5' to 3', it is easier to understand. When we translate this mRNA sequence, we see that we have a protein that is 4 amino acids long, leaving out the stop codon. I'm using different colored shapes to identify the different amino acids. The gold star represents methionine, the purple square represents valine, the blue circle represents serine, the green rectangle represents lysine, and the orange triangle represents the stop codon. Now that we've talked about identifying the sequence of the mRNA strand and the corresponding amino acids, we will take a look at the different types of single nucleic acid point mutations. Single nucleic acid point mutations can either be transition mutations or transversion mutations. A transition mutation can either be a change from a purine to a purine or a pyrimidine to a pyrimidine. Transversion mutations can either be a change from a purine to a pyrimidine or vice versa. The different consequences to these mutations are missense, nonsense, silent, and read-through mutations. Missense mutations are when one amino acid is changed and coded for another amino acid. As shown, you can see in the original coding strand, the T that is underlined is changed to an A in the mutant coding strand. The wild-type mRNA created from the original coding strand codes for the amino acid valine, while the mutant mRNA codes for the amino acid aspartate. This is shown through replacing the purple square with a red rectangle. This is a transversion mutation because the T is changed to an A, which is a pyrimidine to a purine. Nonsense mutations are when one amino acid is changed to the stop codon, thus stopping translation earlier than expected. As you can see in the original coding strand, the A that is underlined is changed to a T in the mutant coding strand. The wild-type mRNA codes for the amino acid lysine, while the mutant mRNA codes for the stop codon. This is shown through replacing the green rectangle with an orange triangle. This is a transversion mutation because the nucleic acid A is changed to a T, which is a purine to a pyrimidine. Silent mutations occur when the single nucleic acid changed and the point mutation still codes for the same amino acid. As shown, you can see in the original coding strand, the C that is underlined is changed to a T in the mutant coding strand. The wild-type mRNA codes for valine, while the mutant mRNA strand codes for the same amino acid, valine. This is a transition mutation because C is replaced by T, and they are both pyrimidines. Read-through mutations occur when the stop codon is replaced with an amino acid. As shown, you can see that in the original coding strand, the T that is underlined is replaced by C in the mutant coding strand. The wild-type mRNA codes for the stop codon, while the mutant mRNA codes for the amino acid glutamine. This is shown by replacing the orange triangle with the red rectangle. This is a transition mutation because the nucleic acid T is changed to C, and they are both pyrimidines.